Given the cubic polynomial p of x equals 2x cubed plus ax squared plus 4x plus b, there are two real constants, a and b. For this case, you see that p of x is 2x cubed plus ax squared plus 4x plus b. And the complex number 1 plus 2i denoted by u is the root of the equation. So u here is the root of the equation p of x equals 0. If u is the root of the equation p of x equals 0, it means that p of u must be 0. If p of u is 0, when u is replaced by 1 plus 2i, p of 1 plus 2i must be 0. Then we can use this to find the values of a and b. Now what we do is we replace x with 1 plus 2i and set p of x to 0. We have 2, 1 plus 2i to the 3, so replace x with 1 plus 2i, plus a, 1 plus 2i squared, plus 4, 1 plus 2i, plus b equals 0. For this part here, we have 1 plus 2i to the 3, so we expand using Pascal triangle, or let's just go a plus b to the 3. This is a cubed plus 3a squared b plus 3ab squared plus b cubed. We'll just use this expansion here. So we have 1 cubed, that is 1 plus 3, 1 squared is 1 times 2i plus 3. Then we have 2i squared plus 2i to the 3 plus a, 1 plus 2i squared is just the expansion, the square of a binomial. So we have 1 plus 4i plus the square of 2i. Then we distribute this. That will give us a 4 plus 8i plus b equals 0. So let's look at this part here. For this part, we have 1 plus 6i plus 3 times 4i squared plus 8i cubed. So that will give us 1 plus 6i. I squared is negative 1. So we have negative 12. And then I cubed is I squared times I, which will give us negative I. So we have negative 8i. So that will give us negative 11 minus 2i. For this part, we have 1 plus 4i plus 4i squared. I squared is negative 1. So that will give us 1 plus 4i minus 4, which is negative 3 plus 4i. Then let's just simplify this. We have 2 times negative 11 minus 2i plus 8 times negative 3 plus 4i plus 4 plus 8i plus b equals 0. Now further expanding, we have negative 22 minus 4i minus 3a plus 4ai plus 4 plus 8i plus b equals 0. Let's just collect the real terms. So we have this plus 4 and b. So negative 3a plus b, the real part, we have negative 3a plus b. Negative 22 plus 4 is negative 18. And then for the imaginary part, so for the imaginary part, we have 4a here. And then we have 8i minus 4i. So we have 4a plus 4 for the imaginary part. And since the right side is 0, it means that the real part must be 0 and the imaginary part must be 0 as well. So from here, negative 3a plus b minus 18 must be 0. That will be equation number 1. And let's look at the imaginary part. 4a plus 4 must be 0 as well. That is equation number 2. From equation number 2, a must be negative 1. And then we substitute a equals negative 1 into equation number 1 to find the value of b. So that will give us 3 plus b minus 18 equals 0. B here must be 15. We have the values of a and b. Part B, state a second complex root of this equation. 1 plus 2i is a complex root. The second complex root must be the conjugate of 1 plus 2i. Then the second complex root must be 1 minus 2i. Part C, find the real factors of p of x. To find the real factors of p of x, for part C, we know that 1 plus 2i and 1 minus 2i are the complex roots. So we have 1 plus 2i and 1 minus 2i. Then these two will form a quadratic factor for the polynomial. The quadratic factor is always given in the form of x squared minus the sum of root. Let's say this is alpha, that is beta. So you have alpha plus beta x plus alpha beta equals 0. That will give us a quadratic root. Now from these complex roots here, we have 1 plus 2i, 1 minus 2i. Then the sum of roots alpha plus beta will be 1 plus 2i plus 1 minus 2i, which is 2. And the product of roots, you have 1 plus 2i times 1 minus 2i. That is just a difference of squares. So we have a value of 5 here. The quadratic roots that we have is given by x squared minus, the quadratic factor that we have is x squared minus 2x plus 5. This is one of the factors that we have. We need to find the real factors, all the real factors. So we know that this is one factor. Then to find the last factor, it must be linear, since the polynomial is a cubic polynomial. Now the cubic polynomial, we can use a comparison of coefficient. We can just compare the coefficient to find the last real factor. The polynomial is given by 2x cubed. A is negative 1, so minus x squared plus 4x plus 15. This is the polynomial p of x. And p of x here has x squared minus 2x plus 5 as one of the real factors because of the complex roots. So we have x squared minus 2x plus 5. And now for this case here, this is quadratic. The last factor must be linear. Let's say the last factor is given by cx plus d. Now let's look at this. X squared times cx is cx cubed compared to 2x cubed. C, this must be equals to 2x cubed. So we know that C must be 2. And let's look at these last two here. This will give us 5d. That is the constant term. And the constant term on the left side is 15. So 5d must be 15. Then d must be 3. Then the last linear factor that we have is Cx plus D. So Cx plus D must be 2x plus 3. Then we say that the real factors are 2x plus 3, which is the linear part, and the other one is x squared minus 2x plus 5. This will give us the real factor. Part D, on a sketch of an Argand diagram, you need to shade the region whose points represent complex number z, satisfying the inequality. The absolute value of z minus u is less than or equals 5, meaning that the distance of the distance from any complex number to this complex number u, and we know that u is 1 plus 2i from the initial question. So the distance from any complex number z to 1 plus 2i must be less than or equals to square root 5, meaning that we actually have a circle with a center of 1 plus 2i and a radius of square root 5. So from here we have a circle, the center is 1 plus 2i, and then the radius is square root of 5. And the argument of z is less than or equals to pi over 4. We'll work on that later. So for this case here, you have an Argand diagram where the center is 1 plus 2i, and the circle with radius square root of 5. Now, in order to draw this properly, you need to know where it intersects the real and the imaginary axis. So you have a circle here. Now that is the imaginary axis. And then we have the real axis. So it is, let's say this is 1, this is I, 2i. So 1 plus 2i is here. That is the center of the circle, and it has a radius of square root of 5, meaning that it's going to intersect the imaginary and the real axis. In order to sketch it properly, we need to know where the circle intersect the imaginary and the real axis. You know, can I just mini, more draw a circle? Let's look at this. If z here is E1 by A plus BI, this A and B is different from part A, B, and C. So yeah, we know that the absolute value of z minus u, so we have A plus BI minus 1 plus 2i. This is less than or equals to square root of 5. So look at the real part. We have A minus 1 plus b minus 2i. This is less than or equals to square root of 5. The modulus is a minus 1 squared plus b minus 2 squared equals 5. Let's just use an equal sign here instead. Okay. Now, when a is 0, meaning that we are looking at the real part that is 0. So when we set a to 0, what we see is that you have 1 plus, well, if you replace a with 0, you have the square of -1, that is 1, plus b minus 2 squared equals 5, so that b minus 2 squared is 4, and b minus 2 is plus minus 2. So b is plus minus 2 plus 2. -2 plus 2 is 0, and then 2 plus 2 is 4. So the y-intercept, the intercept on the imaginary axis, so the vertical intercept is 0 and 4. So it intersects here 2i, 3i, and then 4i. The circle is going to intersect the imaginary axis here. So when we set b to 0, when b is 0, we have a minus 1 squared plus 4 equals 5. So the square of a minus 1 is 1. And over here, a minus 1 is plus minus 1, or a is plus minus 1 plus 1. So a is either 0 or 2. So over here, this is 1, that is 2. The intercept on the real axis is 0 and 2. So when we draw a circle here, we actually have a circle like that. Yeah, doesn't look much like a circle. So that is the circle that we have. That sucks here. So all right. Now this circle has a radius of square root of 5. And then the argument of z, so that angle between z and the real axis must be less than or equals to pi over 4. This is 1, 1 here. If you draw a line passing through this point 1, 1, you have an argument of pi over 4. The argument must be less than or equals to pi over 4. Then that will give you the region that you need to sketch. The second part, find the least value of the imaginary value of z for points in the shaded region. And your answer must be in exact form. Now let's see. To find the least value, that means the least value of the imaginary part of z, that must be the lowest value here. That will give you the minimum value of the imaginary part of z. And we know that this is 2i. So this z value here that we have, this z value must be 2i minus square root of 5. So this is 2 here. And then you must subtract square root of 5 because you have a radius of square root of 5. Then this must be 2 minus square root of 5i here. Then we say that the minimum value for the imaginary part of z must be 2 minus square root of 5.